Hello, my listeners. You're welcome at Muhumuza Naphtali Sciences.com. We are always at your service. This is service above self, whereby you can listen to these videos at the comfort of your home. We are bringing medical education at the comfort of your home. And this is courtesy of Muhumuza Naphtali. And today, we want to look at factors that affect the rate of enzyme activity. In the previous video, we looked at the introduction to enzymology. So make sure if you haven't watched the video on introduction to enzymology, before you watch this, first go back and watch the introduction. That's when you will be able to understand the factors that affect the rate of enzyme activity. And these factors, we look at them, it goes to when you are in the laboratory and you are determining the levels of enzymes, to rule out, to do a diagnosis of a patient. You need to rule out these factors. You have to make sure that these factors are in play to be able to get reliable results. So let us start. Looking at factors that affect rate of enzyme activity. Rate of enzyme activity. And these factors include temperature, crude pH, crude substrate pH of the media, they include substrate concentration, they include enzyme concentration, then they include presence of inhibitors, then we also see presence of cofactors and activators. And sometimes we can also talk about incubation time. So these are the major factors that affect the rate of enzyme activity. And we want to begin with number one, that is temperature. We want to see how does temperature affect the rate of enzyme activity. So number one is temperature. And we can draw a graph whereby this is our graph, whereby on y-axis we have rate of enzyme activity versus temperature. And this temperature is in degrees centigrade, where we have here 10, we have here 37, we have 40, we have 60. And we say that the rate of enzyme activity increases with increase in temperature up to optimum temperature, whereby the optimum temperature is 37. So 37 is our optimum temperature. It is the temperature where enzyme activity is at the peak. So this one we call it optimum temperature. So we see that the rate of enzyme activity increases with increase in temperature up to optimum temperature. And why does the rate of enzyme activity increase as we increase the temperature up to optimum? We know that increase in temperature increases the kinetic energy. What is the kinetic energy? It is the energy that causes collision or faster movement of molecules. And we know in the enzyme we have the enzyme as a lock and the substrate as a key. So when you increase the temperature, this temperature increases the movement. That is what we call kinetic energy. So that the substrates can easily bind to their active sites to form products. But this one continues up to optimum because of this increase in temperature increases the kinetic energy. Then beyond optimum temperature, which we call this one as optimum temperature, the rate of enzyme activity decreases rapidly. And why does it decrease rapidly, especially beyond 40 degrees centigrade, is that the reason is that beyond 40 degrees centigrade, from here to 60 and above, the enzymes being protein in nature, they are denatured or destroyed by the high temperature. So beyond 40 degrees centigrade, we see reduction in activity because enzymes are denatured. Enzymes are denatured. Or you can call them that they are destroyed. That's why we see a decrease, a rapid decrease. So here there is increase because there is increase in kinetic energy, and here there is a decrease because enzymes are denatured. And there is a concept to the biochemistry students whereby we can say, whenever the temperature is above 10, there is a concept of 210, whereby for every 10 increase, for every 10 degrees centigrade increase in the temperature, the rate of enzyme activity doubles. The rate of enzyme activity doubles. That is what we call 210. 210 is that so long as the temperature of the media is above 10, then the rate of enzyme activity keeps doubling as per 10 temperature increases. For example, if I'm on 10 here and I go to 20, here it was maybe 2. By the time I go to 20, I expect it to have doubled to 4. That is what we call 210. And that is how temperature affects rate of enzyme activity. Number 2, we can explain how pH affects. How does pH, number 2, we look at the pH of the media. How does pH affect the rate of enzyme activity? Among the properties, we saw that also enzymes are affected by pH. And we know that each enzyme has its optimum pH, where it acts best. That every enzyme, or what we call each enzyme has its own optimum pH. Optimum pH, where it acts best. If I can put it in a graphical presentation, I can present it graphically. Whereby here we have rate of enzyme activity, here we have pH. And we know that here I can put 2, here I can put 7, here I can put 10. We know that there are some enzymes which act best in acidic. For example, pepsin. Pepsin in the stomach acts very well in acidic pH, and its optimum pH is at 2. And you find another pH like salivary amylase. For it acts well in neutral pH, and its optimum pH is 7. Then we have other enzymes which act best in alkaline. So this is in acidic. This is in acidic pH. This one is in neutral, and this is in alkaline. And we see enzyme like trypsin. Trypsin works better in alkaline pH. But as you can see that for every graph, if I can consider graph for pepsin, that the rate of enzyme activity increases with increase in pH up to optimum, beyond which it decreases rapidly. And why is the rate of enzyme activity increasing with increase in pH up to optimum? Is because this pH favors the binding of substrate to the products. But beyond optimum, the rate of enzyme activity decreases rapidly because this increase in the pH beyond optimum denatures the enzymes. And we told you the denaturation is just a change in the active site so that the substrates can no longer recognize the active site to bind to form the product. That is how pH affects the rate of enzyme activity. The first statement is that all enzymes have their own optimum pH where they act best. And we are seeing, you give examples, and you tell us that when there is increase in the pH up to optimum, the rate of enzyme activity increases. Then beyond, it decreases. And why does it decrease? Is that increase in the pH beyond optimum, the enzyme active sites or the conformational structure of the enzyme is lost. So the substrates can no longer find the active site to bind to form a product. That's how pH affects the rate of enzyme activity. Factor number three, we can talk about enzyme concentration. And enzyme concentration, this is number three, which is enzyme concentration. This enzyme concentration, if I can present it graphically, we know that this is enzyme concentration. This is rate of enzyme activity or enzyme velocity. That the rate of, as you increase the enzyme, if I increase the enzyme, also the rate of enzyme activity increases. So the rate of enzyme activity is directly proportional to the amount of enzyme. That if I increase enzyme concentration, increase in enzyme concentration increases rate of enzyme activity. And why does increase in temperature, increase in enzyme, increase the rate of enzyme activity? Is that if we increase enzymes, if we get more enzymes, we avail more binding sites. So but this one occurs, the disclaimer is the substrate must be sufficient. The food for the enzyme should be sufficient. There should be enough. Because it does not make sense if you increase enzymes when there is no food for eating. So the food must be present. So when we increase enzyme from 1 to 3, we are increasing the number of active sites. And remember, the substrate is present. So what happens is that this substrate, when we increase enzyme, it avails more active sites for the substrates to bind to form products. So increase in enzyme concentration increases the rate of enzyme activity. How? By increasing the number. Increase the number of binding sites. And when you increase the number of binding sites, the substrates come and what? And bind to form products. And that's how increase in substrate, in enzyme concentration increases the rate of enzyme activity. That when you increase enzymes, you increase the binding sites, and when there are more binding sites and the substrates are sufficient, more substrates bind to form products. That is how temperature that is how enzyme concentration affects rate of enzyme activity. Okay. Please, always don't forget to subscribe. Hit the subscription button. Like the video and comments. Your comments are always highly welcome. Let us go to factor number 4. And this factor number 4 is going to be substrate concentration. Substrate concentration. And we want to look at how does substrate concentration affect the rate of enzyme activity. And I like drawing graphs because graphs speak more than words. I like presenting them graphically, whereby here we have substrate concentration, here we have rate of enzyme velocity. rate of enzyme activity, or you can call it enzyme velocity. So we are saying that increase in substrate concentration, increases the rate of enzyme activity up to optimum, up to maximum, up to maximum. The rate, as we increase the substrate concentration, the rate of enzyme activity also increases, but up to maximum, beyond which it becomes constant. And how does increase in substrate concentration increase the rate of enzyme activity up to optimum? Let me first write it that increase in substrate concentration increases the rate of enzyme activity up to maximum. And why does it increase up to maximum is that when you increase here, the disclaimer is enzymes must be enough, isn't it? Because if you increase the food and there are no eaters, then you'll not be doing any work. So here we make sure the enzyme concentration is sufficient. So when you increase substrate concentration, what happens? That increase in substrate concentration, and remember you have enzymes available. So more will come and do what? And bind. More substrates will bind to the active sites of enzymes, and when they bind, they will easily form products. So why does increase in substrate concentration increase the rate of enzyme activity? Is that enzymes are available, they have active sites. So when I increase the substrate concentration, the more substrates will go and bind to the enzymes active site to form products. That's how it increases. But that one goes until it reaches maximum, whereby all the enzymes are saturated, or active sites are saturated. Now there is no more space for, even though you continue increasing the substrate, the enzymes are already occupied. So even though you continue increasing, the rate of enzyme activity becomes constant. Here the rate of activity is constant. And why is it constant? Because the active sites of the enzymes are saturated. Active sites of the enzyme are saturated. So here we need to first free these complexes to form products so that we can bring back these enzymes to bind to other substrates. That's why you see the rate of activity is remaining constant beyond the maximum. Maximum means that all enzymes which are available, their active sites are occupied, busy with the substrates. So here at the plateau, or at the constant phase, or what we call the zero kinetic, this one you can call it zero order kinetics. Then from here to here, it is first order kinetics. In first order, it is because active sites of the enzyme are still available. So substrates come and bind to form products. But beyond maximum, we are seeing all active sites of the enzyme are saturated. So we must first wait for these enzymes to free these active sites before other substrates bind. And that is when it is increased, this one is the first order kinetics, and when it becomes constant, we call it zero order kinetics. That is how substrate concentration affects. Those who are in biochemistry, they will even tell you that when I have the maximum, this is maximum velocity. When I get half Vmax, and I extrapolate my here, I meet a curve and I move here. This one is what we call Michaelis-Menten constant, what we call Km, whereby Km, or what we call Michaelis-Menten constant, is half Vmax, or half maximum enzyme activity. That is how substrate concentration affects the rate of enzyme activity. Lastly, we can look at presence of inhibitors. Presence of inhibitors. Presence of inhibitors. Okay. Presence of inhibitors. And how do inhibitors affect the rate of enzyme activities? We know that enzyme activity is high in absence of inhibitors. In absence of inhibitors, the rate of enzyme concentration, the rate of enzyme activity is high. But if you bring in the inhibitor, here we have substrate concentration, here we have rate of enzyme velocity or activity, and we said that it is directly proportional up to maximum, and beyond maximum, it becomes a plateau. So this is in absence of the enzyme, absence of the inhibitor. But and there are different types of inhibitors. We have what we call competitive inhibitors. There are those which we call non-competitive and those which we call ani-competitive. Let us begin with the competitive. If I bring in a competitive inhibitor, the rate of enzyme activity remains the same, but here with a competitive inhibitor, you'll find the graph will be like this. It reaches the Vmax. This is competitive inhibitor. Then in the presence of a non-competitive, we see it not achieving maximum velocity. This is a non-competitive inhibitor. So how do we put it in writing? We know that in the presence of a competitive inhibitor, here the inhibitor and the substrate have the same configuration. The inhibitor and the substrate have the same shape, or what we call configuration. They have the same shape. So they compete for the same binding site. For example, if I have the enzyme here with an active site, the inhibitor and the substrate, they have the same shape. Therefore, they compete for the same binding site. And because they are competing for the same binding site, in case I increase substrate concentration here, I can overcome the inhibition. It is like if you are pulling the rope, and the other side they are 10, and this side they are 2, of course the 10 ones will overcome. So this type of inhibition, it is overcome by increasing substrate concentration, because all of them are competing for the same binding sites. So if I increase substrate concentration, I overcome the inhibition. That's why you see it attains maximum velocity. But this is different from non-competitive. For non-competitive, inhibitor, this was for competitive, whereby we said the inhibitor and the substrate, they have the same shape, so they compete for the same. And because they compete for the same, I can overcome this inhibition by increasing substrate concentration. Then what about non-competitor? A non-competitive inhibitor. For non-competitive, if I have the enzyme like this, the inhibitor, no, the substrate and the inhibitor, this is the inhibitor, they have different shape. And because they have different shape, they don't compete. They do not compete for the same binding. And because they do not compete for the same binding, this inhibitor binds at the allosteric sites. It comes and binds at the allosteric sites according to induced fit hypothesis. And after binding at what we call the allosteric site, This word comes from a Greek word which aros means other or different. So because they do not have the same shape, this one cannot bind here because it has different configuration. So what happens is it binds at other site, which we are calling allosteric sites. And when it binds to other sites, it causes the change in shape of this enzyme. So this enzyme, when this binds here, it turns like this and changes the shape of the normal active site for the substrate. And when it changes, this substrate can no longer recognize. So you'll find this active site will change its shape. Find we have changed its shape, changes totally its shape, and after changing its shape, the substrate can no longer recognize and bind. And because it can no longer recognize and bind, even though you increase the substrate concentration, this inhibition cannot be overcome. Why it cannot be overcome? We are saying they have different shapes, and when this inhibitor binds at the allosteric site, it causes change in the shape, and then the substrate can no longer recognize the binding site. That is the factors that affect rate of enzyme activity. So whenever you ask an exam that graphically describe any file, always make sure you describe and draw graphs so that you elaborate more, so that we are able to always pass our exams. Thank you so much in this video for watching up to the end. Always remember to subscribe, remember to share with your friends, and remember to like the video and put your comments there. We shall be glad to always reply to you. I remain Muhumuza Naphtali, sciences.com. Thanks for listening.